Hey, Julie, I don't think we can hear you.
Thank you, Anne. Good morning, everybody, or afternoon, wherever you are. Welcome to the live stream for the ArcGIS Maps SDK for JavaScript. We're going to be talking about some of our favorite updates. My name is Julie Powell, and I'm a product manager joining here from San Diego. And I'm here with some of my great colleagues. Maybe Jose, you can introduce yourself.
Yes, I'm Jose Bañuelos. I'm a product engineer and I work on the web editing side. And I'm based here in Redlands.
And Arno.
Hi, my name's Arno. I'm a developer evangelist for the team working in Zurich, specifically on all of the 3D capabilities in the Maps SDK.
Thanks, Arno. And how about Anne?
Hi, everyone. My name is Anne. I'm a product engineer working on the JavaScript SDK based in Los Angeles, and I primarily work on symbology, some visualization, arcade, and a bunch of other fun things.
And Andy?
Hi, I'm Andy. I'm also a product engineer on the JavaScript SDK team. I'm in bright, sunny Boulder, Colorado. I work on geometry operators, frameworks, performance, ES modules, and other fun stuff.
Thanks, Andy. And Christian. Oh, you're muted too. So it's not just me.
Sorry. Christian Ekenes, based out of Redlands, California. I work on data visualization capabilities in the SDK.
Thank you. And definitely everybody that's joining, post in the chat where you're joining from. And we'd love to see where you're coming from. We have Hector from Guatemala and Ricardo from St. Mary's, Pennsylvania. Yeah, share where you're joining from. And we're going to kick it off with Jose. And by the way, as we are presenting all of our updates, feel free to post your questions in the chat and we'll answer them as we go along and also at the end. So, Jose, let's see what you got.
Thanks, Julie. So I'm going to demonstrate some of the features that we released for web editing this fall. And so I'm going to start off with one of our biggest features, and that's displaying a two-dimensional grid on your map. So it's a set of vertical and horizontal reference lines that can be used when you're drawing or sketching in your applications using JavaScript SDK. So the grid is configured through the grid controls widget, which is embedded in the sketch and editor widgets out of the box. And some of the configurations you can do with the widget is you can set the origin of the grid. You can use the placement tool as well to set that origin as well. You can rotate, you can adjust the number of cells in between major lines. So this shows 7 right here. You have the ability to update the theme. So from dark to light theme, and even set a custom color. So I'm gonna set this to a blue. So you can set the grid better kind of fits the base map you're using as well. Also, you can take advantage of dynamic scaling for the grid, which adds or removes cells based off the current scale to give you a good grid to display on the map. And once you turn off dynamic scaling, you have that set number of grid cells between major lines, so that's not going to change when you turn off dynamic scaling. Another functionality is the ability to snap to the grid. So we can see the snapping visualizations as we draw this polyline. So it's a great reference tool as you're drawing features on your map. As I mentioned, the grid, uh, the way to configure grid is out of the box in Sketch and Editor widgets. So I'm just going to show an example with editing, and here we're going to draw a parcel. I'm going to enable snapping on the parcel layer because not only can you snap to the grid, but you can use the grid placements tools to snap the origin to existing features on the map. So I'm going to snap to one of the parcels, and this looks like a good grid. So I'm going to zoom in. So if I now draw a new parcel, I can say that this parcel is about 4 grids in the width, and for the length about 9 grid cells long. So this is an example of how you can utilize the grid as a reference while you're drawing or editing features on your map. FeatureTable had a lot of new enhancements this release as well. One of the first things I'm going to talk about is the support for subtype group layers. So viewing and editing subtype group layers. So here we have a sublayer from one of the state subtype group layers on the map. And with the ability to edit subtype group layers, whenever you update the subtype field value, you get prompted whether you want to keep your current edits or default to the default values in the new sublayer. Here we can also see a new enhancement, and that's the ability to set up your table template. So with the table template, it allows you to configure your columns to better organize your table. So here I created a state information column, group column, and in this group column we have a state name, state abbreviation, and state population columns. So to provide some more information on the state we're looking at for each individual record on the table. So it's just a better way to organize your content on your table. And also another big feature is the new support for attachments. So if you enable attachments on your table, you will have an attachments column, and then you can even see a preview with the thumbnails of the attachments. In this case, for the California record, we can see a small preview, and we can even view the images as well. You can add, delete, and even download the attachments. And finally, if you select at least one record on your table, you'll now have the option to export selection to a CSV. So if you wanted to take some of this data from the table offline and download it to a CSV file and share it that way, you now have the ability to do that. So yeah, that's some of the functionality that we added in our 4.31 release of the JavaScript SDK on the web editing side. So thank you, and I'll pass it back to you, Julie.
Thanks. That was great, Jose. All right. So next up is Arno to give us some updates on 3D.
All right, 1 second. I'm sharing my window. All right, I hope it's coming through. I'm going to talk about some of the 3D capabilities that we released in the last release, starting with Viewshed. Actually, we released Viewshed last summer already in 4.30 for the user conference. However, we did work on some of the samples, and I quickly want to call them out. This first one here, which is using not one, but two scene views. So we have the viewshed analysis in the scene, and we also have this in-view scene view here on the lower right, basically showing us what the viewer would see from the point of view of the viewshed, which is kind of cool. So while you interactively change the viewshed or place it and change its properties, you can see what that would look like from the viewpoint of the analysis. So that's one sample showing the interactive capabilities. Then one of the things we did add for Viewshed in this release is the support for persisting the viewshed in slides. And I'm going to switch to the full screen version here to better show this. So one thing that is being used here is different viewpoints together with the viewshed analysis being persisted in the slide. So we can iterate through the different scenarios or configurations here, showing a planned development and its impact on existing buildings for a viewshed analysis. But we can also change the analysis and load this from the slides, which is persisted in the web scene, together with a viewpoint here showing how you can have multiple viewsheds in a single view, or then also the possibility to create a view dome from the viewshed analysis, which is basically extending these handles to the 360-degree to create a view dome analysis. One other feature I would like to talk about quickly is a bit more technical. This is the visible area. So far, you could always ask the scene view, like, give me the visible extent in the scene. Here we also have a sample, and I'm going to switch to the full screen version of it. However, in 3D, the problem or the challenge that you have is that the visible area is not necessarily an extent as we have it in a top-down 2D view. Instead, it's usually a more complex geometry depending on the tilt and the direction of the camera. And this sample here explains the concept of the visible area. You can see here again in an overlay view, in a map view, what the current visible extent is, and you can see that it's not an extent, rather a geometry. And you can query this visible extent and use this, for example, in client-side queries, if you want to really understand what exactly is inside or outside the view that you're looking at. And this sample here is using this to query the number of different trees. So while I'm changing the camera, these numbers here adopt and basically tell us how many palm trees or oaks are in the view right now. And this is especially helpful when, for example, creating dashboards or other client-side statistics to really understand what the user is looking at and make sure that these numbers correspond to the features that are shown in the scene. And one last feature I want to quickly mention is something that you have been able to do previously through the API, but now we added support in through the UI, so you don't have to go and change the properties in the public API of the SDK, and that's the field of view. So I'm using the scene here of Zurich, showing an integrated mesh together with a water layer and reflections to show this feature. But what you have to do or what you can do in any application that's based on the Maps SDK and using a scene view is you can press Shift, and then you can change this field of view. You can decrease it to go towards an isometric view, but you can also increase it to put more of a like a wide lens view. Create a wide lens view, which I'm doing here in Scene Viewer. And this gives a more immersive, so in this sample, it gives a more immersive view of your 3D data. You can persist this in the slides, it gets persisted, and then you can also share these camera settings across other apps in ArcGIS. And yeah, that's basically it from the 3D side. I'm passing back to you, Julie.
All right, thanks, Arno. That was great. We actually have a question about feature table from Preem. Can we have the table with item ID instead of using service URL? So that would be for the feature table. So Jose, if you could, do you want to take that question?
Yes. So you can actually load, like the sample I showed, I'm loading the web map, and then I'm just grabbing one of the layers from the web map and assigning it to the table. So you can either load the layer from a portal item or grab the layer from an existing web map. And you can also persist the attribute table template that I mentioned as well to save some of those settings.
Yeah, so like sort order of the rows and the column order, all that can be configured in the map viewer that you can just load into your application via the web map or the feature layer item. Pretty cool.
That's correct. I also noticed there was a question for the grid. It's asked if it can be configured with different spatial reference and coordinate system. And yes, the grid actually adjusts based off the spatial reference of the map. So if you're using a projected coordinate system, we're actually going to display a spacing input where you can even adjust the length of the cells. We do that because for the projected coordinate system to get a more accurate reading, and more accurate measurements. With geographic coordinate system, we turn that setting off because you don't get that accuracy because of distortion with geographic coordinate systems.
Thanks, Jose. Okay, so we have Anne is up next to talk about animated symbols.
Alrighty, let me go ahead and share my screen. All right, so hi everyone. I'm super excited to talk about symbol animations, which we just released in beta for 4.31. So these animations can be used to help highlight the freshness of data or to draw attention to specific features. And there's 6 new animation types that are supported on point symbols or marker symbols in SimSymbols. So we have the color, offset, rotation, scale size, and transparency. So let's take a look at these in action. And when I'm building a sim symbol or a multi-layer vector symbol, I typically start with the sim symbol builder. This is a tool that helps you add different symbol layers and set the different properties on your sim symbol. And then you can easily export it and get the symbol JSON. So here, for the sake of time, I've already added 2 vector marker symbol layers to my map to create this shield with a hiker symbol. And you'll notice now at this latest release, we have animations that you can set either on a specific symbol layer. So if I just wanted to animate, say, the hiker symbol itself, or I can set the animations globally on the entire symbol. So you can see all of the different symbol animation options here. I'll go ahead and select scale. As soon as we add that, we can see all of the different animation properties. So the scale factor, how much is it going to scale by, duration, easing, repeat type, etc. So let's just see what this looks like in our symbol layer right off the bat. Maybe I want to make some tweaks, like I want it to oscillate instead of loop. I could change the easing so that it eases in and out. I could set a short repeat delay. All right, so now I'm pretty happy with how my symbol looks. Then I can go ahead and get that symbol JSON. So I'll just copy that out and I'll move over into this application that I designed to just animate when I click on a symbol. So here I'm just going to update my symbol here in the sim symbol reference, and we'll automatically refresh, and we can now see that we have our symbols all animating. I'll go ahead and change this so that the play animation is set to false. And now we just have those static symbols. And then what I want to do is perform a hit test to, when I click on a symbol, I want to update that so it starts to animate again. So here I'm cloning the symbol, and then I'm setting the play animation to true, and then reapplying that symbol directly back to my graphic. I can also set use like the JavaScript set timeout to, end that animation after a certain amount of time. So I think it's pretty powerful what you can do when working with the animations. And this is just an example with graphics layers, but what really makes the animations powerful is working with feature layers and different data attributes and primitive overrides. So in this example, that's a sample in the SDK, we're looking at earthquakes that happened in the past month and using the animations to highlight earthquakes that are greater than a 2.5 magnitude that occurred in the past 12 hours. So really just drawing attention to those latest earthquakes. And this is done with 2 different animation types and also primitive overrides, which allow you to connect data attributes in your data to property values in your symbol. So here you can see I have my sim symbol, and here I have the primitive override set. So I'm setting an override on the play animation and also the color properties. And this accepts either just a attribute value or an arcade expression. So here I'm setting an arcade expression where the magnitude is greater than 2.5, and also using the arcade date diff function to calculate the features, the earthquakes that occurred in the past 12 hours. And then if we go and look at my symbol, I'm setting the animations directly on the outline symbol layer that you can see. That's the only thing that's animated. It's not the entire symbol. It's just one symbol layer. And so I'm setting a scale animation and also a transparency, which does this kind of grow and fade kind of thing. So yeah, that was just a few examples of animations. I think they're really powerful when combined with arcade and these primitive overrides. There's a lot you can do and a lot you can show to enhance your applications. Yeah, thank you so much. I'll hand it back to Julie.
All right, great. Thank you, Anne. So next up we have Andy that's going to talk about geometry operators.
All right. Can you see my screen?
Yep, we see your PowerPoint.
All right. Thanks, Julie. Geometry operators are brand new. They were released at beta at 4.31. And what I want to do is I have just a couple of slides because they are brand new and want to capture some of the frequently asked questions. And then I have some demos. These geometry operators will eventually replace Geometry Engine. It's essentially a complete rewrite under the hood. It's bringing brand new capabilities. And of course, we fixed a bunch of bugs in the process. And it will eventually allow for curve support. For those who aren't familiar with geometry operators, these allow you to provide 2D capabilities on the client for geometric operations. And it's not just points, lines, and polygons. You can also use multi-points and extents. So geometry operators, there's 38 of them that overlap with the existing Geometry Engine capabilities. But what's really exciting is the 23 brand new operators that bring essentially pro-like advanced capabilities to the browser. These are sync only. If you want to do async operations and get the functionality off of your main thread, you will need to use web workers. And we also have, for spatial operators, the ability to provide what we call acceleration capabilities. So what does this look like in code? Just to give you an overview of what the new functionality looks like, you can run operations, multiple operations using the execute many method, which is on all the operators, or do a single operation, which is execute. And here's an example on the bottom of accelerating a geometry. This is for spatial relation operators. And essentially what it is, if you want to run the operation multiple times against a single geometry, and in this case we have a buffer geometry, it will provide a performance benefit. So that's pretty exciting. Here's the 23 new geometry operators. I know that's a big list. Just mention a few: alpha shape operator, minimum bounding circle operator, multi-point to single point, geodesic proximity. There's a lot there. I definitely encourage you to check this out. To help you get your brain around all of this functionality, since there's 61 of these, we've created a new SDK page under spatial analysis in the guide topics, under geometry operators, and we've tried to group them into 8 functional categories, such as bounding, densify and generalize, of course, spatial relationships, and transformations. We also are going to be building on additional documentation to support these with topics such as dimensionality and, of course, acceleration that I just briefly mentioned. We also added a new sample, and there's more on the way. This one shows you how to do centroid and label point analysis. And the concept behind this particular sample is it's showing if you want to put the centroid here. We have a state feature layer. The red dot is showing the centroid of that particular polygon. If you wanted to add a label to this polygon, we're using the label point operator as well, which is the blue square. The centroid's the red circle. And of course, there's the centroid of the center of the extent that surrounds this polygon. Underneath the hood, what we're doing is we're taking an input polygon, we're running the operator against it, and we have an output polygon. And here's that execute method that I talked about. Here's another example of some of the power, the new power that we're bringing to this. We're all familiar with round ends on buffers. We have a graphic buffer operator that gives you the ability to change how the caps and joins work on buffers. Here we've changed the buffer to have square ends. We can also change the cap to be a butt end, for example, and we have all sorts of different ways to tweak the capabilities of this. So if you were to look in the API reference under graphic buffer operator, just wanted to quickly show you some of the capabilities in addition to adjusting the joins and cap styles. You can also get down into the details, and this is where I say we really encourage you to dive into this. So you can change the max deviation of the result buffer, maximum number of vertices in the full circle, miter limits, and so much more. I wish I had more time to talk about it. The last demo that I have is a geodesic buffer operator. In this case, we have a new pattern that I wanted to show related to loading the projection engine. And in this case, we offer a method that lets you detect when you're using an operator that loads the projection engine, the ability to detect if it's loaded. If it is, you can lazy load the projection engine, so you don't have to load it up front in your application and take that initial performance hit. And then, as we've been talking about, you can run the execute method against that operator and graph your result on the screen. And with that, I'll turn it back to Julie.
All right, thanks, Andy. Okay, so next up we have Christian, and he's going to talk about some new capabilities around feature reduction.
All right, let's get my screen up here. There we go. Andy, I also wish that you had more time to talk about your stuff because I think geometry operators are really cool. But this is also awesome. So we, at the latest release, expanded support for clustering and binning. Previously, you could only cluster and bin point data. Now you can do it with any geometry type. So polygons or polylines can also be clustered and bin. And just as a recap, what clustering does is it aggregates data on the fly spatially so you can see relative density of features. So let's take a look at this new example that we have in our documentation called clustered polygons. So I've got a layer representing swimming pools. As you can see, when I pan around, I can see the swimming pools just fine. And you may wonder, well, why in the world would you want to cluster that? As I zoom out, I can still see that this is a pretty good scale to view that data. But if I go out further to the whole extent of the city, it becomes really difficult to tell what's going on because these aren't point symbols. There's the quantization effect coming into play that makes it difficult to really see the rendered data. When I click this enable clustering button, you'll see that clusters will now appear in my view. So I can see a summary of the relative density of these pools in the area. So if I click on a cluster, you can see all the same capabilities that I have with point clustering, where I can get a summary with statistics. I can even browse my features and look at the individual pop-ups and locations of pools. And nice thing about clustering is that it's dynamic. So as I zoom in and out, those clusters will explode into smaller clusters. And I can even see individual pool locations represented as a marker symbol. So
Hey,
it's nice and easy
Christian,
to see.
sorry to interrupt you. I think the screen's not being shared, so if we could get the Christian screen up there.
Okay,
Just seeing your video and my video. Let's see.
let me try this again. Can you see that now?
Yes, I see your video. Okay, yep, now we're good.
We all good?
I
Okay.
have to rewind the tape just a little bit. Sorry.
No, we're all good. So now that I know that nobody saw what I just showed, we can kind of start that over. So I got swimming pool data here. I don't need to explain that anymore. Just want to give you a look as I pan around, but then get you a nice view of when you zoom out, that data becomes very difficult to see. So this is a good data set, a good candidate for clustering. So when I enable clustering, I can now see the density of the data in my view here. So I can click on the cluster, get the pop-ups. I can even see these individual locations represented as markers, whereas if I disable clustering, it's virtually impossible to tell individual features very clearly. You can even set a scale threshold. So that's what I've done here. So if I show you the code down here, um, I have feature reduction, so I set the type to cluster. I've just set a simple renderer. This renderer is not necessary when you point cluster, but it is when you do clustering on polygons or polylines. So that's just a little slight difference in our implementation. And that the main reason is because we can't infer styles from other geometry types because the clusters are points. It's easy to do that, a point-to-point translation from the layer to the cluster, whereas from polygons and polylines, it's difficult to do. But I just wanted to call out this max scale property here that allows you to control when the clustering is applied or when it's removed from the layer. So if I zoom in, the clusters will explode into small clusters, and then it will eventually turn off at a scale where it makes sense to view the regular the swimming pools. So it's a really slick, easy technique to use. It's the exact same API as what you do for point clustering. Same is true for binning. So the difference with binning and clustering is that binning will use screen or geographic space. So it's not dynamic. So in this case, if I zoom in to these bins, you see that they're not changing in size. They're not exploding to different sizes. It's all fixed. So if you want a fixed density, which is very common, you can definitely do that with binning. But I want to show this specific example with bridges along rail networks in New Zealand. So at this scale, the data actually looks pretty good. It looks like a nice map of rail networks, but it's actually a misleading map because as you zoom in, you will see individual line features that are actually quite small. And when you zoom out, it appears that they're much longer and that the entire network is made up of bridges, which it's not. So when I enable binning, again, using the same binning API we've had for a couple of years now, just set my feature reduction type to binning, um, I can summarize that data to those various bins. So what I've done here is I've colored each of the symbols based off of the predominant rail line, as well as changing the size based off the total bridge length. So you could do it by total bridge count or bridge length or whatever statistic you want. So if you look over to the code on the left, I have a property for fields right here. So I can get my aggregate count. That's the total count of features within the bin. But then I can also say, well, I want to sum the total length of each of these or of all the bridges within the bin to create a sense of how much bridge is in this area, not just by count, but by total length. And then I can use this field that I've created in my renderer. So if I go down to my size visual variable, you'll see that total length field used there. So similar to clustering, I can set a scale. So as I zoom in, those bridges locations come into view at an appropriate scale, and then they will be aggregated to bins as I zoom out. So it's a really nice, slick way to represent dense data that otherwise would not look very good at certain scales, or it's misleading. Now, this doesn't work for all data sets, and you can get away with clustering points pretty much on any data set that's dense, but when it comes to lines and polygons, you really got to be careful with misleading your users. So for that reason, we've updated our clustering and binning guides. to give you some tips and tricks on how to do that. So if you'll look at this TOC to the right, you'll see a new section called Clustering Polylines and Polygons. And this will give you some guidelines on when it's suggested or okay to cluster those types of geometries. And it's the same with binning. We have the exact same section. A lot of it, there's a lot of overlap, but there's also a few differences. Generally speaking, I've put in bold what makes the most sense. So if you're working with really small features like the swimming pools or the bridges are a good example, but also other things like culverts or connectors or buildings, these types of things are really well suited for aggregation at various scales. And they also should be regular in size. So if you have widely varying sizes, then it's probably not going to work well. But that's all I had to share. There's 2 new samples and the updates to those guides. So I'll go ahead and pass it back to Julie.
All right, that was really great, Christian. Thanks. Okay, I'm going to show a really quick thing. Share my screen. Let's see here. Okay, so this is a map of Yosemite National Park and a nice little view of the John Muir Trail. What I wanted to show is now we have support for embedding a map. So if you have the most simple scenario where you just want to simply embed a map in your app, you don't have any customization needed, you can do things like setting the mode between light and dark, putting a map title, legend, bookmarks if you'd like. And here you can see the different controls that I've enabled here in the application. And then I simply just copy this HTML and then I can embed it in my application. So this is actually, obviously it's being shown within Map Viewer, but this is being powered by a new web component that's part of the JavaScript Maps SDK. So here in references, you can see all the different references that we have. This is the new one, the embeddable components reference. So you can click on that and have a look at the sample and then turn the different things on and off using the storybook and then copy the code into your application just like you saw me do directly from Map Viewer. So this is a really handy way to just quickly embed a map. If you have any requirements for customization in your application, this is definitely not the approach to take. You should be using the map components directly. But this is just kind of the option you have when you just want that simple map and you want to put some controls onto your application. So that's what I wanted to show. We had one unanswered question that we wanted to address, and that was about FeatureTable. There's a question about overriding the sort function when you have a virtual column. And so, Jose, do you want to answer that?
Yes. So that's a great question. And so the reason we currently don't have support for this is due to some performance reasons. Because right now, for non-virtual columns, the server handles the sorting for us. But with virtual columns, we would have to kind of handle the sorting and maybe even provide a way for a user to provide their own way to sort, because the columns are not restricted to text and number input, so it could be any other column. So sorting there adds an additional complexity. So yeah, because of the performance with the virtual columns, the client having to do a lot of the work, at the moment it's currently not supported. But yeah, if we keep getting more feedback, we can look into that for future.
All right, thanks, Jose.
Yep.
So I think we can get everybody back on screen and say hi and bye to everybody. Thanks everyone for joining. Definitely remember to like or subscribe to our channel and join us in the future. Thanks for joining.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.